লাইভ অপশনে যাও না আমার ভিতরে। Okay, good evening. I think I am audible. Okay, so yeah, you can just 1 minute. Okay, students, so let's start today's class. I hope you remember last class we learned about relation. Of course, today also will do on relation only. Just give me a few seconds. Yes, let's start. NCERT. Please share with me. Yes. Okay, I hope you are all good. Let's start today's class, and you can please write here whether you can listen to me or not. You can keep chatting since we are studying. Okay, so we have done one question last time. Yes, on parallel straight lines, right? Today we will be doing we are going to do some question that is very important, as well as let us do simple question one. Okay, first simple question one. Here we have to find domain. Find domain and range of the relation. What is the relation given here? Relation given R equals to x comma y such that x square plus y square equals to 25. X comma y belongs to I. Okay, now you have to find domain and range of this relation. Now tell me in this question, look here, x and y belongs to I means an integer. That means we shall take the integral values. Like integral values means what? 0, plus minus 1, plus minus 2, plus minus 3, like that, dot dot dot. Right? So what we can do? Here following x square plus y square 25, and if we take it Pythagorean triplet, we know what we know, that 3 square equals to 4 square equals to 5 square. As Pythagorean triplets is 3, 4 and 5. Okay, these are the Pythagorean triplets. Now here you see you are getting r from that way. You can take 3 comma 4, of course you can take, because 3 square plus 4 square equal to 25. Also you can take 4 comma 3, because again 4 square plus 3 square equal to 25. That means x is equal to, once you can take 3, once you can take 4, right? Now you can take it like that. If you take minus 3 minus 4, also possible, because minus 3 whole square plus minus 4 whole square equal to 5 square, 25. If you take minus 3 plus 4, also possible. And you see, if I take minus 4 minus 3, also possible. Also if I take plus 3 minus 4, that also possible. Check. 3 4 4 3 minus 3 minus 4. Here minus 3 comma 4 minus 4 comma minus 3, 3 comma minus 4. Like that way we can take. Can I take any other values? Can you please tell me? Here we have x and y coming from integer. Tell me, can I take 0 comma 5 and 5 comma 0 or not? Because 5 square plus 0 square also equals to 25. Yes, very much. We can take 0 comma minus 5 also. You can take minus 5 comma 0 also, right? Now whole thing you got the answer. I hope you understood, right? So actually what is given here, that you have to check nicely. Is it integer? Is it natural number? If it is natural number, no, we cannot take minus, we cannot take 0, like that things. So you have to be very much clear. Okay, you have to take very much clear. Now please tell me, what are the domains here? You can do comment please. Students, you got here domain. Earlier also I told what is domain here. This question is given here, what is domain? So what did you find? First, if you take the smallest one, we'll take 0. After that you got minus 3. After that got plus 3. After that got plus 4, minus 4. After that plus 4. After that 5. Sorry, minus 5, 5. Check it whether you got the same or not. Right? Now see, what is the range here? Range also equals to, same way you will get it, what? Same, right side also same, 0 same, minus 3, plus 3, minus 4, plus 4, minus 5, plus 5. You can write it like that also, 0, plus minus 3, plus minus 4, plus minus 5. I think yours is not visible. Okay, so I think now you can see, right? So I hope it's clear. So you got the domain and range, right? Let me do one more question. Okay, the question is what? Question is, I'm writing the question first. You please see this one. Question is here, prove that the relation is perpendicular to, okay, the relation is given here is perpendicular to on where? On the set of straight lines, straight lines, obviously in a plane, is symmetric but neither reflexive nor transitive. If this is the question, I have to those you got the link from the WhatsApp or something like that, please enter inside the YouTube, that you can do chat also, please. So you go to the channel and enter from there. The live option is there, you can go, because it's open, no problem, anyone can enter. So I can see you also, and we can comment. Okay, so we can interact. I think it will be very better, very good. So I want to prove this. Now, as I taught you earlier also, whenever you try to solve these types of questions, two things you find. First is the set. Let us take set A. What is set A here? Set A, you can write x such that x is a straight line, in a straight line in a plane. Or else you can write set of straight lines. Both you can write. You can write this also, you can write this also. Now you understood? Like this straight line, this straight line, this straight line, this straight line, like this straight line, all look like this now. These are all straight lines. You can see it like this. Now I have to prove what? The relation is what here? Relation is x comma y in this form such that x is perpendicular. I wrote a short form. It's perpendicular to y, and x comma y belongs to set of straight lines. Okay. Now, if I take x is perpendicular to y, take these two things. Let us take these two. This is x, and this is y. So x is perpendicular to y. Now x is separate, y also separate. So these two are perpendicular. But can I tell x itself perpendicular? This is perpendicular to this? No. How come it will come? It's not possible. So here you write x can't be perpendicular to itself. X can't be perpendicular to itself. Like x perpendicular to x, not possible. If it is not possible, so x comma x not belongs to R, or x R x not for all x belongs to A. For any x value it is not possible, right? We are writing the answer only. So that means you can understand what R is not reflexive. So first case is, we check it what we did here, reflexive case. Now next we do here symmetric case. Symmetric. What is the symmetric case here? X comma y belongs to R means what? means x is perpendicular to y, like this. X is perpendicular to y. Also I can write y is perpendicular to x. This is also true? Yes. So if it means that x is perpendicular to y, that means what? Y is also perpendicular to x, and that means, or that implies, y comma x belongs to R. So what you understood? What you understood here? That R is symmetric, means x perpendicular to y implies y perpendicular to x. This logic you have to understand. This logic you have to understand. Then it will be okay, right? Next, see this question. I hope you understand. Okay, if you like it, you can give like. Also you can comment there. Okay, let's do the next question. It's also one of the most important question that also comes NCERT. Many times it came. Okay, so you can also expect this question. Next case is transitive. Okay, next case is transitive. Look, let 3 x y z be 3 straight lines. If x y z be 3 straight lines and x perpendicular to y, y perpendicular to z implies, see, just take this picture like that. It is x and it is y. It is x, it is y, and it is z. So what is the finally got? X parallel to z. That means, see here, what you are understanding here? That x comma y belongs to R and y comma z belongs to R implies xz not belongs to R. Sir, why not belongs to R? Because x and z, these two are what? These two are parallel. They did not become perpendicular, right? So we can say R is not transitive. I hope it's clear. Okay, so let's do one more question. Yes, my dear. Let's do one interesting question that is from little complex type, but I hope you'll understand. What is the question here? Let R be a relation. Let R be a relation in n cross n, which defined by a comma b are x comma y, if and only after, this is called if and only if, what, ay equals to bx, prove that R is an equivalence relation. Prove that R is an equivalence relation. Now what we can do, solution part. See, here actually the set is taken n cross n. Be very careful. Here the set is, the given set is what? A equals to n cross n, means cross product of n and n. Okay, means it's like that. What? So here the given set is A equals to n cross n. It's just like, it can be how? It can be 1 1, 2 2, 3 3, 1 5, 1 6, like that. All things will come. That means you can take it like that, x comma y, such that x comma y belongs to natural number, just like that. This itself is a set. And the operation what you are doing, that means relation here is like that. Relation is here, just a comma b comma x comma y, such that a b x y all belongs to n, or a comma b belongs to n cross n, like that. This, it's not completed, it's given a y equals to bx in this format. That means, check here, is the first and last and second and first multiplied here, a y bx. Please keep it in mind. Right? Now see, you are doing like this, you got the relation, or else you can write like this also, a comma b r x comma y if and only if a y equal to bx. So for you this process will be easier, so I'll take this process because here many things are coming, you may have confusion. So let me show how we are solving. Okay, first is we'll check for reflexive. In case of reflexive, what we have to do, we have to take both same. Okay, here a comma b or a comma b, it can happen what? A into b equals to b into a. But is it possible? Yes, it's possible. A b b a. Now see, a b equals to b a. Why? Here multiplication is commutative. Earlier we have done like this. Okay, maybe you have done in a class, that is for addition is commutative, here is multiplication is commutative, right? So a b equals to b a, multiplication is commutative. So if a b equals to b a, then this value is same, and it is following this. Here actually a b is as it is, but here x y become a b. So it is following. For all a comma b belongs to n cross n, or you can write a comma b belongs to natural number. Anything, it's up to you. Right? Next is, so you got what? R is reflexive. Done? Next is symmetric. In case of symmetric, what I have to show? I have to take ABXY and I have to take XYAB. So here A comma B are X comma Y. If it holds, that implies what? AY equals to BX. Check it here. Again I am showing it here. AY first, last, second, first. That means here also same AY BX, right? Now can I write BX equals to AY? Yes, I can write. That's possible for us. But sir, why you are writing? Let me complete this. And I am changing XB equals to YA. Why sir? Because again multiplication is commutative. Multiplication is commutative here. That rule is following. Okay? This commutative rule is following. Now, if I take XB, so can I write X comma Y? That implies R A comma B. See, here also is following first, last, XB, yes or no, and second, first, following, right? That implies R is symmetric. That means R is symmetric, right? Next, transitive. In case of transitive, we have to take three elements. Yeah, it's visible now. Yeah. So in case of transitive, we have to take three. What are the three? A comma B, X comma Y, and let us take P comma Q. That all belongs to where? A equals to N cross N. Okay, I have taken from there. So now if I take two case, A comma B are X comma Y. That implies what? First, last, second, first. That is what? AY equals to BX. And if I take X comma Y or P comma Q, that implies what? Again look at this. Same way you do first, last and second, first. That means what? X Q equals to YP. I hope it's understandable to everyone. Right? Now, check it here. If I take this the first relation and this side the two relation and multiply 1 and 2. If I multiply 1 and 2, what you are getting? AY X cube BX YP. Can I write? Sure. Look here. Multiplication is commutative. So we can cancel yx and xy. So if we can cancel both sides like that, check it here. Yx can cancel. what you are getting actually? AQ equals to BP. See here, remaining here, first is AB and second is PQ. So AQ, that means we are getting A comma B R P comma Q. How come we are getting this? Check it here. AQ is here, yes or no? And BP also here, yes or no? From these two relations we are getting this. That means R is what? Transitive. R is transitive. So last final what you got? R is reflexive, symmetric and transitive. Therefore R is, we can write R is an equivalence relation. No doubt on this, my dear students. So I hope you could understand this one, right? Okay, so let me do one more question. So that is done. So let me do one more question. That is also very interesting. So it's like that. I'm writing the question here. Please comment how it's helping you. Okay, let R be the relation in S equals to 2, 3, 4, 5, 6 by X or Y when X minus Y is divisible by 3. Write R as a set of ordered pair and examine if R is an equivalence relation. Okay, now we'll do the solution part. In solution part, already the set A, already we take one set A, actually here S equals to given 2, 3, 4, 5, 6, that's all. And the R is given here, what? How is given? X comma Y such that it's written here X or Y means like this, X minus Y is divisible by 3. Of course X comma Y belongs to set, here set S. Okay, now see what are the value we get. My dear student, tell me, if I do 2 minus 2 equals to 0, 0 divided by 3, yes, you can divide 0 by 3 equals to 0, like that. So you are getting 2, 2, you are getting same way 3, 3, you are getting 4, 4, you are getting 5, 5, you are getting 6, 6. Okay, that means first case you got taking all. Now next case what you can take, if I take 2 3 means 2 minus 3, no. 2 minus 4, no. But if I take 2 5, that means 2 minus 5 is what? Minus 3, and modulus will be plus is divisible by 3. So we can write 2 comma 5. Also we can take 5 comma 2, that opposite also. Next case, with 2 6, no, not possible. Next let us go to 3. If I take 3 6, because 3 4 3 5, not 3 minus 5 is minus 2, no, but 3 minus 6 is minus 3, or 6 minus 3 is 3. 3 comma 6 and 6 comma 3 will get like that, right? So all these things you are getting. I think this is the last, we will not get any more. So 3 2 5 5 2 3 6 6 3, that's all. Now check. First we have to check whether it's reflexive or not. In reflexive case, here 1, no, it's not 1, sorry, 2 3 4 5 6 all belongs to S, and 2 2, we are writing all because here a small number, that's why not very big numbers here, only 5 6 numbers, that's why I'm writing here 2 2 3 3 4 4 5 5 6 6. That belongs to what? R. If that belongs to R, so can I tell, yeah, let me keep it here that you can see nicely. Yes, this is the R values are here. I think it's clearly visible to you. Yes. Now see, 2 2 comma 3 3 comma 4 4 comma 5 5 comma 6 6 belongs to R. That means all are present here. Yes. So you can write R is reflexive. Next case we'll take it symmetric. In case of symmetric, what we can do? In case of symmetric, what we'll do? Look at this here. This 2 2 3 3 4 4 5 5 6 6 no need to take, but 2 5 5 2 3 6 6 6 3 also following. So here you write 2 5 belongs to R, implies 5 comma 2 also belongs to R, and another is there 3 comma 6 belongs to R, implies 6 comma 3, vice versa. So you can understand that R is what? Symmetric. Very simple. Next, coming to transitive. Check here. All are same 2 2 3 3 4 4 5 5. That can only to take. So here you can do like that. 2 comma 5 belongs to R, and if you take 5 comma 2 belongs to R. So what is here? A B B C. So finally what you are getting, that implies 2 2. Final is 2 2, and look at this, 2 2 belongs to R, and also you are getting 6 comma 3 belongs to R, and 3 comma 6 belongs to R. What is this here? This is A, this is B, this is B, this is C, and what is the last? A, C, that's 6 6. If I take this first, it will be what? It will be 3 3, whatever. So here 6 comma 6 belongs to R, so on. Okay, means, yeah, I think it's very good. Means what you are getting, that R is transitive. So what is the final conclusion you got? Here R is reflexive, symmetric, and transitive. So R is an equivalence relation. Is the proof. R is an equivalence relation. That is the finish. Okay, so the relation part will finish here. Okay. So today we will wind up here, and next let's do. I'll actually please subscribe the channel and please comment also. Please like this. You will get notification if your notification bell is on. So maybe Wednesday or Thursday again we'll meet with the next chapter, that is function. So today we'll wind up here. So bye, stay safe, stay healthy. See you next.